in the course of reviewing your homework with you, reteach a little of what you missed out on yesterday. There is an old saying in the world, you reap what you sow. Has anybody ever heard that before? One person? Anybody else? Two? Okay. You reap what you sow means this. To reap means to harvest, and to sow means to plant. So, if you were a farmer, and you had a field, and then next to it you had another field, if in the first field you planted a bunch of corn, and in the second field you planted a bunch of broccoli, when it came time to harvest, remember you planted corn seeds and broccoli seeds, when it came time to harvest, what do you think you would get out of the first field? Corn. And what do you think you would get out of the second field? Broccoli. You wouldn't expect to get peas out of the second field, would you?
No.
You would not expect to get cauliflower, would you?
Maybe.
No. You would expect that the kind of thing that you planted into that field, as long as you cared for it right, is what would grow up in that field. Okay? Now, likewise, if you think about your schooling, if you plant the seeds to success, what do you think is going to grow? Success. When we say you reap what you sow, what it means is whatever you plant is whatever you get to harvest. And that's this universal law in life. Some people call it karma. I like to say you reap what you sow. Some people say you're getting your just desserts. But the fact of the matter is, if you think that you can be lazy about something, and you think if you can be irresponsible about something, and not pay attention, and then all of a sudden, when it's time to get your grades at the end of the year, or let's think even bigger picture than just that. Let's think in terms of, graduating and going on to something better in life, whether that better is going into the military, whether that better is starting your own business, whether that better is college, whatever you would want it to be. You really don't think that you can sit here and plant everything that suggests a poor future. Like if when you come to school you don't do your work, and if when you come to school you forget your pen every day, and if when you come to school you don't do your homework, and when you're given the opportunity to go over your homework you don't really pay attention, and then when you're given little quizzes and then you don't learn from your mistakes on those quizzes, do you really think that at the end of 5 years of doing that, that when you harvest your future, it's going to be a strong, bountiful crop? No way. You have sown the seeds of a future where it's going to be very difficult for you to get by. Did I ever tell you the two things you need to do to stay above the poverty line? If you do these two things, there's like a 99% chance you stay above the poverty line. First off, what is the poverty line? Poverty line is the amount of money at which, if you live under that line, you are pretty much guaranteed welfare, guaranteed food stamps, guaranteed dependency upon the government. You never want to depend on the government. Never. If you're down, a hand from the government is a very good thing. When my grandfather's dad, God bless you, in the early 1940s, he broke his back. And they would have lost the house if it wasn't for government help, and my family went on welfare. So that's not a bad thing. But if you intend to live on welfare forever, that's a horrible thing. Now, if you want to never be in that situation where you depend on others, there's only two things you need to do. Number one, graduate high school. Number two, don't get married or be forced to have a kid before you graduate. Do those two things.
Graduate what?
High school. Which means be 18 years old. If you do those two things, statistically, there's a 99+% chance that you will have all the money you need when you get older. Unfortunately, some kids don't graduate, and some kids have babies when they're too young. And when that happens, it's very, very difficult, because now you have to not just afford yourself in this world. What else do you have to afford? The kid. And the kid takes away all of your money, and the kid takes away all of your time. And if you don't have time and you don't have money, it's very difficult to work toward a good future for yourself. Okay? So, when I see you guys come in the room like today, telling each other, hey, settle down. You weren't mean about it, you weren't bad about it. I know we're pumped up from running around outside, so let's settle it down. Let's get to work. Perfect. It's exactly how you want to be. I can't ask for a better class than that. Okay, so I want to pay attention to the bottom here. Excuse me. Now, God bless you. I want to make sure, we'll go through a couple of examples back and forth of reviewing a little bit of scientific notation. This is extremely important stuff on your state assessment test, okay? First one, this is, I wrote one form here. I must have had a brain cramp. I should have written standard form. Okay? And this one, I wrote other form. I should have written scientific notation. Now, these two are equal to each other. See, let me just give you a little hint as to where scientific notation comes from. Anybody here Italian? All right, Italians make the best food. Have you ever noticed that?
Amen.
All of the above, lasagna, not the, what you got served today at lunch, that was cardboard and wallpaper paste. But real lasagna, made by an Italian. Eggplant parmesan. It's so good. Well, you know what the problem with eggplant parmesan is, right?
Too much sugar.
No.
Too much fat. Too much fat.
Eggplant, in the words of Peter Lowry many years ago, my wrestling manager and great, fantastic, amazing kid. Eggplant makes you fart. So, you gotta be careful with that eggplant. But Italians, assumbuco.
What's that?
Who made pizza?
He'll say that's so
Oh,
good.
fast.
Now,
The
quiet.
Italian pal.
Now, the Italians not only make the best food.
They're awesome.
Italians, they are awesome.
Hey.
Italians also is good at science,
You also speak Italian.
right? And there was this Italian guy years ago by the name of Avogadro. That was his last name. You can tell he's Italian because his last name ends with a vowel, and that's kind of very famous for Italian people.
Okay, well, I'm
Greco.
extremely Italian.
Right, Greco.
My family is insanely Italian. My grandpa makes the best lasagna, and I love science, and I get like 98s.
There you go. So
I
now,
don't like science.
in the essence of the Italian history for food and science, Avogadro wanted to figure out how many molecules of air, or any gas, fits in 1 cubic meter at standard temperature and pressure. That's pretty good for not being able to see the thing as I was drawing it, right?
Yeah, that is good.
Now, so you got a box 1 meter on each side. The meter's about this long. You want to know how many molecules fit inside that box. Don't ask me how he did it, but he did it. This is the number of molecules that fit in that box.
That's amazing.
Ready?
1 trillion. 1,200,000.
One.
Oh. I can read it.
Octillion.
Zero.
Quintillion, septillion.
I don't even know what tillion this is. Now,
What number is that?
it's called Avogadro's number.
Go.
And it's 6 point, now here's the thing. Let's say that we're talking about how many cubic meters there are in school, in the entire building,
Well,
so that we can calculate how much air is in the building. My guess is, if I did the number of cubic meters in the building,
They're gonna be trillion.
it's gonna be a massive number. Let's just say 175 million.
a million.
That's no longer.
Now, here you got this guy Avogadro. He's sitting around, and he's computing how many molecules you've got in his science lab or whatever, and he knows he's got to multiply, right? Like if you guys were saying, look, I got 5 buckets, and each bucket holds 2 gallons, how many gallons would you have altogether? Right? 5 buckets, 2 gallons each. How many gallons altogether? 10. 5 times 2 is 10. Well, in this case, he's saying I got this many containers, like buckets, and each container holds this many things. So he says, I got to multiply. So Avogadro turns around and does this. Ready? Can you see that this is going to get real ugly real fast?
Yes.
Okay. So Avogadro says, there's got to be a better way.
A calculator.
Well, they didn't have, he invented this back in like the year 1500.
Oh.
So, no calculators, no electric.
Why?
I love
That's
it.
the way it was back
For
then.
nature.
Very natural, only outhouses. So, at that point in time, Avogadro says, how can I do this better? And he invents this thing. I don't know if he invented it or if he just used it and somebody else invented it. Called scientific notation. And this is where we're going with today's lesson. So I'm actually going to show you a little piece of today's lesson. And then I'm going to show you, go back, work on the homework a little, and come back to the lesson. He says the following.
Can't see.
This is just a whole bunch of zeros with the numbers 6, 0, 2, and 3. So he says the zeros, I can kind of, it's not that you can ignore the zeros, but I shouldn't have to write them out every time. You see, mathematicians are 2 things. They are brilliant. Yeah, they are.
Thank you.
And they're lazy.
Thank you.
They do not want to write out anything more than they have to. So he says, how can I do a better job of working this out? This thing is actually called a mole, the number. Short for molecule. So he goes, this is 3, 6, 9, 12, 15, 18, 21, 22, 23 places until he gets to the 6th. I'm going to round off just a little bit here. Technically, the answer is 6.023 times 10 to the 23rd power. 23rd power because that's the number of places the decimal moves until it arrives there. Okay? Then he looks at the next one and he says, well, that's going to be 3, 6, 7, 8. And he writes down 1.75 times 10 to the 8th. Now, I'm going to do a little bit of quick rounding off here because it's in my head and so on and so forth. I'm going to round this off to 2. And he would say then, if I wanted to multiply these 2 things, and I'm going to round this off to 0. He would say this is 12 times 10 to the 31, and then he might get a little fancier and call it 1.2 times 10 to the 32. But look at how quick I did that multiplying. Like that. Done.
What?
That's what you're going to learn over the next couple of days. What I want you to realize is this. He took these really big, long expressions, which took forever to write out, and I could do all of the math in less time than it took me to write out the zeros. Okay? And he did that using this concept of scientific notation. So this is why we study scientific notation. And it fits very much in with the laws of exponents that we already know. For example, if I do x to the 2nd times x to the 5th, what do I get? X to the 7th, good. And if I do 2x squared times 4x to the 5th, what do I get? 8x to the 7th. Now look over here. What's 6 times 2? 12. And what's 23 plus 8? 31. So in other words, I'm using the laws of exponents with scientific notation numbers. And that's really what the next 4 days is going to be all about. So, I get back to this guy here, and I say to myself, okay, the regular form is 3,400. What's the scientific notation form? It's 3.4 times 10 to the 3rd. That's because I moved the decimal 1, 2, 3 places. 3.4 times 10 to the 3rd. Okay, see? 1, 2, 3 places. Let me go to 100,000. If I started here, 1, 2, 3. Am I at a number between 1 and 10 if I stop here? No, that's the number 100, so I gotta go again. 10 is still too big, I gotta get down, so I go there. And I get 1 times 10 to the 5th. Now, look at this one, and let's go backwards to get that answer. Watch, ready? 3, 6, 9, uh-oh. I should have put another 0 there, another 9, another 3. 10, 11. And that would give me 3.9, and I moved a total of 11 places, times 10 to the 11. Let's look at this one. Ready? What do I got here? 3. What do I got here? 6. What do I got here? 9. What do I got here? 12. 7.00025. I got to include all the non-zeros. Times 10 to the 12. I don't know. That is a 12. It just didn't look that. All right. And the last thing is this stuff about negative exponents. Negative exponents are whenever you do like 0 point, and you make it super small like this. 0 point, and then I'm going to go 1, 2, 3, 4. So since I go 0 point, or I make a number less than 1, that means I'm going to have a negative exponent, and I get 3.1. 3.1 times 10 to the negative 4. Okay, so that's a quick, brief review of what we didn't get to yesterday. Now, we get started on the new stuff for today. So, oh, I need to open up today's folder, excuse me. Excuse me. I forgot to open up today's lesson sheet, so let me do that right now. School. Oh, got to get my glasses on. Today's number is 10 or, no, it's 9. I don't want that, I want this. All right. So now, guys, let's bring that focus back. Now what we're going to do is work on your do it. And I remember saying to you guys, let's make sure we get that do it done right away. So, if I want to do, let's do number 2 before we do number 1, because this is like what we worked on before. And I'm going to work on this one first. How many places? Ready? Go ahead. How many places did I just go? 3,
6, 9.
9. And that gives me 1.54, which is what I want, times 10 to the 9. Very good. Okay. Now, as soon as you look at this guy, and you see 0 point. As soon as you see 0 point, that means it's going to be a negative exponent. 1, 2, 3, 4, 5, 6. That makes 0.55. That's not big enough. 7. So 5.5 times 10 to the negative 7. Okay? 5.5 times 10 to the negative 7. All right, let's take this one here and let's work on it. I start with 1.2, 1, 2. Now, I know the decimal point's here, but I have to move this guy a total of 5 places to the right. So if I go 1, 2, 3, 4, 5. And now if you need to go backwards, wouldn't that make sense? 1, 2, 3, 4, 5. 1.2 times 10 to the 5th. So this answer is 120,000. This guy, I see the negative exponent, so I know it's 0 point. I got to move a total of 4 places. The 3 is one of those places. 1, 2, 3. The 3 makes the 4th place 0, 8. And now if I count them, 1, 2, 3, 4. 3.08. So I know I went to the right place. It's 0 point, so my exponent should be negative. Okay? Last but not least, the edge of a cube can be represented as 2D. Volume of another cube can be represented by 5D. Oh, this is really tough. What's the sum of the volumes of both? I did a lousy job of typing out this question. This says the edge of the cube is 2D. If the edge of the cube is 2D, then if I want to compute the volume, cross, that's that way, it's this way, it would be length times width times height, which would be 2D times 2D times 2D, head in the game. 2 times 2 times 2 is? 2 times 2 times 2 is? 8. And then I gotta add exponents, d to the 1, d to the 1, d to the 1 is d to the third. So that represents the blue cube. It tells us, see, this should have said the edge of another cube, but it doesn't. It says the volume. So I just have to add 5d. Okay? Because they want me to add the two volumes, and one, you can't add, Frankie, you can't add cubes and regular d's. Okay? Any questions? All right. So now let's get to today's lesson. Okay. Now, these rules are a lot like the exponent rules. Let's get your feet down. If we do the exponent rules, we know the exponent rule says multiply coefficients, add exponents. Once again, what do I do to coefficients? Diego, hit me again. What do we do with coefficients, guys? No. Listen carefully. Multiply coefficients, add exponents. Everybody, what do? Multiply coefficients, add exponents. So an example very similar to what we did before. 2n cubed times 5n to the fourth. What is that going to equal? 10n to the 7. Good. Let's take the same idea and apply it to these two. The coefficients would be the 3's. So what is 3 times 3? 9. Times 10 to the add coefficient, add exponents. 10 to the what? 9. So 9 times 10 to the 9th is the answer. So it's very similar to what we already know. Try the next question underneath that, just the first one. Okay, so once again, what do I do to those coefficients? Multiply. What do I do to the exponents? Add them. 2 times 3 is 6 times 10 to the 4th times 10 to the 10th. 10 to the 14th. Very good. Multiplying coefficients, 2 times 3 is 6. Adding exponents, 4 plus 10 is 14. Now this is a division problem. With division, you don't multiply the coefficients. What do you do to the coefficients? You divide them. Okay? What's 8 divided by 4? 2. And what do I do to those exponents? You subtract them. Very good. 9 minus 4 makes? 5. Excellent. Try the next question. Uh-oh. It's a whole lot easier than writing out all of those zeros, right? Yep. Definitely don't want any part of that.
What's that?
These are Tylenol.
They're like added.
Yeah, when I get weather like this, my sinuses kick. So that will make me feel better. Well, it won't make me feel worse anyway. So, multiply coefficients, subtract exponents. What's 5 times 7? 35. And what's 10 to the 3rd times 10 to the 24th? Guys, what do we get here? 10 to the
4. 4.
27. Multiply coefficients.
Ours says something
We
different.
said something different. It says 10 to the second.
Yeah.
Oh, yours just says 10 to the 2nd?
Yeah.
Sorry, okay, so then it would be 5.
The 4.
Which
4.
one?
Both of them
Oh,
are
both
2.
of them are 4?
Yeah.
Okay. So I will get 35 times 10, they're both 2 you mean, right?
Yeah.
All right, so 35 times 10 to the 4th. Sorry about that. Now, here's the problem. Ready? The problem is that's not in scientific notation. Is 35 between 1 and 10?
No.
Do not back up. Look here. 35 is not between 1 and 10. So again, I have to move the decimal one place to make 3.5. Then this has to become times 10 to the... Now, to do this, I divided by 10. So I have to balance that out by multiplying by 10. So I have to add exponents. Remember, 10 really has a 1 on it. So the final answer is 3.5 times 10 to the 5th. 35 times 10 to the 4th is equal to 3.5 times 10 to the 5th. But this is not the proper form. Listen, if you know anything about me, never mind, I'll tell you tomorrow. All right. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios amigos y amigas. Cheerio. Garusharus. Gadafis. Miss Harris, if you learn to be responsible as a student, it looks to me like you might be one heck of an artist or fashion designer one day. Could be good at that. Know what I mean? But we got to work on that responsibility. Like going to that website, interestman.com, so you can stay even. Know what I mean? All right. See you later, folks. Have a great day. Hasta la bye-bye. Beep, beep.